Record. All right. So here we are again today with the Game Dev coaching with Daniel. And Daniel's here and has the code up on screen sharing, which is good. So I think the first thing we should probably look at with this code is what happens when we change the border thickness here. Oh no, it's like, why can't I live edit this? And it's because it's not in the right mode. Let me just adjust my configuration manager.
I only have the one screen today, so unfortunately I can either look at my code or look at yours and create the infinite mirror in your screen. So that'll be interesting.
Yeah,
as I'm on a laptop.
That's really causing the video to get a bit interesting. Do you have a way to like put them side by side? If you put mine on the right side, I think with the video it should overlap correctly. Yeah, and then if I make yours bigger and put mine over the top, that looks fine for me. Does that look fine for you?
Yeah, that's workable.
That's much better. Yeah, let's do that. Okay.
Okay.
So, so I think I should edit and continue with schedule project. Oh. So yeah, I'm trying to get my little edit and continue trick working, and it's not. So I might just have to keep rebuilding it. So what I was going to do is I was going to be like stick 15 in there, and
I see,
and see what happens. And so that's one sort of interesting issue that comes up that I think is probably worth looking at fixing. So
is that simply because I've forgotten to put the?
So yes.
Okay, go ahead. Well, obviously I'm not projecting at the right time, but also there's latency, so I'll be quiet and you can talk.
That's all right. So I'll just stick that in there, and so now you can see where the like bug is coming from, and like that I'm not sure we were recording at that point, but you noticed that it was like sort of off by 1, and you get this.
That's right.
This little issue here.
And just for background, the assignment, which I think came through email, is basically after we finished drawing our line last time.
Yeah.
Which isn't online yet, but the last time we drew a line, and then this time we're, augmenting that with an outline that should give us the similar.
Yeah.
It's the same function, but outline. So yeah, a couple of things are wrong, obviously.
So I think what we want to do, first of all, is I'll just move that over here somewhere. Window management. Okay, so I think the first thing we want to do is fix up the issue with the origin. So you remember last time we had that trick, like
top left origin becomes the half width or whatever.
Exactly. So we're working on a 1 by 1 pixel texture. So if we stick the origin at new vector 2 5f 0.5f, let's just stick that. Now, I'm not a huge fan of all these 1-letter variables, but that's just a matter of taste, really.
I don't usually do that either. I don't know why I did that. But.
Yeah. Well, like, it's interesting to experiment with, but I have to say that when I went to read it, I'm like, R is rotation scale.
Yeah.
Maybe it's like.
Well, it should be. You know what? Honestly, I would probably just call that in real life. I'd probably just call R angle.
Yeah.
Because that's actually what it is. And V would be our actual vector that we're using, and S would be scale, and P would be the perpendicular.
Yeah.
And then L, I don't know. This is me like lateral lines. Like I don't know. This is the vector for the sides of the not the long slats, but the things that we're screwing up right now. So I don't know what to call that. Other than these actually are the perpendicular line vectors, not the perpendicular itself. So maybe I call this perp vector or something like that.
Ah, yes, because so this is where it gets a bit interesting. So there was so I've set this up. Yeah, no, sorry, hang on. That's correct. I'm sort of fumbling this while I'm talking. So this is sort of with the correctly set origin. So you can see here that I've set it to 0.0 and 0.5.
Right.
I'm using the same origin for both. So what's happened is, and if I can bring up drawing, here we go. Let's bring that over to my side of the screen. And it's. I feel so constrained with this.
Yeah, we're making it work today.
Okay, so what's happened is, let's see, we've got this 1 pixel white square that is getting, so I think, well, the top one was a red line, so that's our texture, and we're stretching it up like that for this line here. And so we've got the origin there, and the stretch happens that way and that way. Right. With the green line, what's happened is, in some cases, you've got the square and you are taking it and stretching it that way is like the major, like if that's L and that's thickness, you've got L is now going this way and thickness is going that way. And so what happens, particularly if you set an origin here, is you get length becomes like this big line there, and thickness, you get like a line that's going that way, stretched from the origin here, whereas what you actually wanted was like you actually wanted like that business.
That's right.
So sort of one of the main points of the exercise, like this is an okay way to do this, but I think like what I was intending and what I think would work a lot better is instead of doing this would be to be like line and reuse this line method here, because we know that this one works correctly.
Right.
And so do you want to?
I thought about doing it that way. That was at first I was like, forget this. Why am I not just making a rectangle? That was my first thought. And then my second thought was, well, yeah, I can just call the line method multiple times. And then I guess I got kind of in the weeds about determining what the actual endpoints are going to be. But I think it might end up being a little bit simpler, right?
Yeah. Well, simpler at least. I mean, it's maybe a bit more maths, but the maths is more straightforward perhaps, because what you've got in this situation here is you've got you're working out the start point, and then you've got the start point, and then you've got end point, and then
I mean the first two draw calls are the long parallel lines, and then the next two are the perpendicular lines drawn at the beginning and the end of the first parallel line.
Yeah, so let me try and draw this out, because I'm trying to figure out what you've got going on. So let's see, we've got the start, and then we've got what must be the end, and then start plus P. So P is...
this is just to move down.
Yeah,
the
perpendicular of that is false. Counterclockwise. So let's just assume it's down. I'm gonna...
That's right. Yeah, counterclockwise. So it's clockwise, so it's down.
Yeah, and that's so S plus P. And so what you've got going on is you've got a line coming out that way, and a line coming out that way, and a line going that way, and a line going that way.
Right.
And in all of these, like all of these cases, they're using the same angle. Like,
yes,
you've got the angle here, and you're rotating around there, but you're using basically two different sort of textures. You've got one that goes that way, and you've got one that goes that way. Or I should say, you have one going that way, and you have one going that way, and you're then rotating them both by the same angle into place.
Yeah, I understand now how that's not the same thing as using math to determine the actual lines I'm drawing.
Yeah,
as logical lines.
Yeah, so like that's like this is almost right. Like there's a few minor issues with it that we looked at, but you could get it working this way. Like it's I don't want to say it's wrong because it's a possible thing you can do, but there's this idea that if you did it another way, which would be like we start there and do that, and start there and do that, and start there and do that, and start there and do that. At the very least, that would be it at least forces you to do the maths in sort of a more rigorous way. I guess is one important thing. So I think do you want to try and do this live, or do you want to save this for later? Do you want to?
Yeah, I'm happy to give it a try.
Let's give this a go. So let's start with what you've got as far as the things you've already calculated, because maybe those come in handy, and just whack in 4 line calls, and let's see what happens.
Well, let's see. Okay, so I think my first line I'm going to attempt to do, just put in the light pixel stuff. I think the first line can be a lot like the first line already is. I mean, the first line is going to be the start to the end, obviously. Wait, hold on. Wait, is it? I don't know because of that origin thing, but if we're going to use that origin, we'll use that origin that you were using. So
well, yeah. So what I was going to maybe point out was what we're trying to do. We have that nice big, already drawn it. If I've drawn sort of over the top of it, we've got this nice big red line here that we're drawing.
That's right.
And so what we want to do is we want to basically figure out that point, that point, that point, and that point, and draw between them. So we have to go from this is like start, and this is end.
Right.
So we have to go perpendicular and out between start and end. So that's the shape we're trying to make.
Okay. Yeah. Right. Okay. Yeah. I see how I. Okay. So anyway, wait a minute. This isn't the. This is. See. That's around here. Oh. So yeah, we don't actually need that. So we just need it.
So I've already.
This is the height. Oh,
I've already filled in. I've already filled in like the things that we know are going to be the same.
Right.
So all we need is like foo and bar, and we know that although we have 8 things here, we actually only need 4 points. So there's going to be like, you know, we might have there A, B, C, D, and then like, you know, A to B and B to C and C to D and D to A.
No, I understand. I'm actually just way back here with method line has 6 parameters, but is invoked with 7 arguments. I'm trying to see where I
yeah, you
made a mess.
Angle in there.
Oh, duh. Yeah. Right. Okay. So, okay. So So A is start, and B is end, and C is equal to the, well, just, I mean, why not just take this and D is probably the one I don't know. Well, actually, isn't it? Wait, isn't C start plus that? Isn't D end plus that? Maybe.
Hmm.
I'm not sure.
Well, we can give it a go.
And see how bad it is. A to B. We can do B to. Oh wait, no. B. If we're doing B to C, then C is actually end. Anyway, this is going to be wrong, but I'm going to give it my best chance. Wait, A to B, B to C.
That was a good catch, because I think you're right about that too.
B to C, C to D, and then D to A. I don't know. Live a big life.
Let's F5 that sucker. That looks pretty good.
Yeah, other than it's not really.
Well, do you want to bump your thickness up so that you can see what's going on? I think is.
What is your value?
I used 15. There. I'm going to bump that down slightly, I think.
Oh. What?
So I just changed it. That to 10.
Yeah.
Yeah.
Oh, oops.
15 is also good.
Okay, so now, oh, why is mine different than yours?
That's a good question. Let's find that out. Because is it because your origin is different? Is because the origin is not the same for the line. So I've gone ahead and made that same change up here in the line method.
Ah, okay, yeah, okay. So basically, yeah, I see. Okay, so you're going to put this up here because this isn't actually even used for our line here because we're using the line method.
Yeah, so we can get rid of, in fact,
most of this. The only thing we need.
V. That's all right. Okay, so if you run that now, that looks pretty good. Let's verify that this is exactly right. So let's set these both to 200 and make this a little bit transparent. Excuse the truck. What the heck happened there? Oh. Yeah, I need to move both of them down, the start and the end. So now they both have the same start and end. So see what happens on yours when you do that.
Wait a minute, that can't be right. I did something else wrong.
Yeah, I just like the start and the end have to move down.
Well, aren't they exactly the? Sorry.
So we're trying to make we're trying to make them overlap. So your start point for your first line is 100 and it should be 200.
Oh, duh. Yeah. Yeah, everything else looks fine.
Mm-hmm.
Okay. So basically the outline one is down half because I'm not subtracting the origin.
So
somehow
we're almost right. So let's draw out what's happening. Where's the drawing? So we've got, okay, so this is start, and this is, now let's really highlight these with some pink. We've got this point here at start, which is A, and then we've got B is end, and then we're adding P, so we're actually going A.
I lost you.
Okay, so you've lost my video.
Yeah, I lost your video. Okay,
I
that's
lost
better.
yours for a sec too, yeah. Quality hotel internet. Right, so we've got A and B, and that's start and end. So you can already sort of see what's going wrong here. Because, you know, the start and the end are not actually our 4 points that we're going for. And then we're adding P, and obviously P, we add P and we end up down here. And we've got end plus P, and we're ending up down here. And so we've got C is down here and D is down there, and this is the line we've got. So those are the 4 points we've got, and we're making that line there. Which means that we need to adjust A, B, C, D basically to move the whole line up a bit. So are you following what's happened there?
Yeah. I was just thinking we just need to maybe subtract that origin value.
I'm
C&D, I think.
I'm not sure what you mean by the origin value, but yeah. So we basically have to move the whole thing that way. And so
yeah, unfortunately the lag on the draw is such that I can't see what you.
Oh, it's not synchronized with
yes,
the audio.
No, just because of the latency.
Yeah. Okay.
But
So
I understand. Yeah.
We're trying to move it up this way, and so basically,
right.
You need to figure out what I'm running out of colors. This length here is, I guess, this one in blue.
Okay. Well, that's just going to be the length of the perpendicular divided by. Couldn't we just?
Mm-hmm. That's your audio dropped out a bit there, but it sounded like you had it. So.
Hopefully.
So do you want to code that and see what we get?
Sure. Length of the perpendicular divided by.
Still there? I seem to have lost video.
Oh boy.
Oh, I can hear you.
Well, let me get me back my crazy P value. Move it up. I don't know, I'm kind of lost now, but I was trying to basically slide A up by the half of the length of that perpendicular. That would have been, wait, no. I have to multiply that first, or height divided by 2.
Mm-hmm.
And I mean, this is kind of a whole bunch of stuff to write, but I would probably want to do the exact same thing to end.
Okay, so let me stop you here.
Yeah, sure.
Because what you want to keep in mind is that you can scale vectors directly. So
right.
Try and do exactly what you're doing, but lose the new vector 2, and just try and do it just with vectors. And I think.
Well, I thought I only was. Oh, I see. I thought I was trying to basically like really affect the y component, but I can easily do that by multiplying by a vector that has a 1 for that. I just gotta, I don't, right, I'm here. Okay, so, okay, let me try again. So I'm gonna take the, I'm gonna scale this by, wait a minute. Okay, to scale this backwards, I need the vector that I'm gonna scale it by is gonna be the perp of v, I don't,
That's all right.
Divide. So, but I only want, I'm trying to take the perpendicular that I would have, like this whole thing here.
Let's simplify this a bit. Let's take that out because we know that's p. We know that's p. So take p out and make a variable for p. And in theory, you shouldn't need to call perpendicular or normalize or multiply the height again. So try
right.
this.
And this is just gonna. Okay.
Yep.
Okay. So I'm gonna. I just want to move it, so I'm gonna do vector addition because I just want to slide it up, and I'm gonna slide it up by. I forget my coordinate system, but I want to put negative p divided by 2.
Sounds like a reasonable option. So do you want to finish? Let's finish filling that out and see what happens.
Okay. Well, this is the only thing. I'm going to slide all of these up by the same thing. So why not? I don't know. We'll see.
All right, let's run that and see what happens.
Okay.
Hey, that looks pretty good. If you make the
yeah, I don't like the corners.
Sorry, I missed that last one.
The corners are rounded.
Yeah.
Which isn't my favorite thing.
Well, okay, so do you want to scroll up a bit and just make the outline transparent slightly?
Yeah.
And then you'll be able to see if it's lining up properly. So does that look centered? That looks centered to me.
Yeah.
So let's go scroll back down to that code that you just wrote. So there is one simplification we can do here, and I'll give you a chance to figure out what that is.
Well, I'm plussing a minus, I guess, so I could just remove the plus. Well, maybe not.
Yeah, well, I mean,
yeah.
Give it a go. I'll tell you can.
That's what I figured. But that's the first one, and plus p minus p, so I can kill those two too. Oh, wait, no, I can't. That's my stupid first outer inner last whatever.
Yeah.
Bedmass or foil or one of those darn things.
What is it?
Back in the day.
Order of operator.
The
actual name of that escapes me.
Oh, first order. Yeah. Okay, so that's still the same as it was.
So that's okay. That's the same code as it was before. So keep going.
Well, I got rid of those pluses. Okay, so n plus p divided by 2. I can multiply p by 0.5 instead of dividing because that's actually better,
right? Yeah.
I know that's probably not what you're after there. But.
No, well, I mean that's a reasonable thing to do, though. So why not?
So there's that, and then minus p times plus p minus p times. Well, if I'm taking away half, but then I'm adding 1, why not just positive 1? So I'll just go like this.
That looks pretty reasonable to me.
And then hopefully this is still the same. Yay, it's still the same. Okay.
Yeah. Okay.
I think, is that it?
Well, the only other thing you could do is you could say 0.5f, and this is just an optimization. We'll just take the whole thing and
sure,
do that. Yeah. But that's almost like that sort of is straightforward.
Just collecting all these single letter variables.
And so and now we have our lovely line, and you can hopefully see now that that is it's what do I want to say? It's like it's this is a lot less maths. I've lost the code we had before, but it's a lot less maths. So it's actually a lot less complicated than the thing you were doing before.
No, I agree. Yeah, I got so fixated on just trying to like just getting that perp function.
That's all right. So let's roll down to the perp function.
Maybe we don't need the configurability of this.
Well, yeah. So there's two things we can do. First of all, like this is a bit ugly for like game development stuff. It's like this is going to be a conditional branch, which the processor will probably predict. But I mean, you're always this. This is more of like a coding thing, and it's sort of a performance thing. But it's like you're always going to call this with a constant true or false. So you may as well split this out into two functions.
Understood.
So let's do that now.
The only reason I wasn't even going to do two functions. The only reason why I have two functions was because in my previous version, if I used a clockwise perpendicular, it didn't draw anything. So I'm like, oh, what the hell? Okay, I'll try the other version.
Yeah.
But yeah, I understand. So like perp CCW and perp CW. Yeah, that makes sense. Yeah.
Now
I would have done it that way. I didn't.
I think that was. Which one do we want? I think we wanted clockwise.
Either one works at this point, but I guess it doesn't matter which one.
Yeah, that's actually true. Either one will work because they're they're rotationally the same, because we're both adding and subtracting the same value. But on that topic, there is a sort of mathematical thing, and this is sort of one of those things where you want to be a little bit like a little bit rigorous about, because it's the sort of thing that if you don't think about early, can bite you in the ass. And that is particularly in what we're doing here. Let's bring up that. So in our current coordinate system, we have, y is down and x is across. Whereas in like a standard Cartesian coordinate system, it's like x and y plus is up. And so what you're doing is, if you are rotating, let's just say 90 degrees that way, it actually changes depending on what coordinate system you're in. So in this case, this is 90 degrees and 270 degrees or negative 90 degrees. And this one is clockwise, whereas this same one is counterclockwise. So you sort of want to be careful using that terminology, because it changes depending on your coordinate system. So this perpendicular function that that we have here that's a very simple function. Like, we might want to use that in both coordinate systems, and so the name doesn't work in well, depending on which one you've chosen as the coordinate system that you've named it by, the other one is wrong. So what you want to generally do is call one of them perp 90 and one of them perp 270. Because in that case, it's always going to be going to be correct. But we now having said that, let's just check, because I just slapped that in there. Let's just actually check that we're doing the right thing. So 90 should be, if we have if we have positive x, so if, sorry, let me scroll. Thinking about this, if we have x equals 1, that becomes one becomes y equals 1 in both cases. And if y equals 1, then that sort of rotates 90 degrees up here and you get that business. So and it becomes x equals -1. And this is just the same maths we did the other day, which means that so y equals x and x equals -y. So, and that's prep 90. So yes, so we have, well, you have, I can see your code, and mine is the same. So yeah, so this is the correct, like these functions are correct, and we could go ahead and like write the test case and check that, but I'm pretty satisfied having drawn that out that that's correct. So cool. Do you follow all of that logic there?
Yeah. Yeah, I was, that I spent the time last time, so kind of got it. And then, but what about the rounded corner thing? This is just bothering me that there's sort of like this.
Okay, so, I wanted to show you a thing. I'm not sure I can actually bring that up just yet. After the stream, I'll bring up something. I'll show you, because you've already seen my rounded lines. That are all pretty and stuff, and yeah, I can see why they're bothering you, because they are ugly, these things, particularly when you're like trying to abut them at the corners.
Yeah,
like if we've got yeah, there's two lines there, and then that's ugly as sin.
We almost have to do like 4 perpendicular, 2 more perpendiculars at those corners for each corner, just to get the piece that's missing out of the slot.
So you want to just fill that in? Is that what you're thinking?
That's like I know we could do it even fancier with a rounded corner, but yeah, we probably want to give the person calling the outline function the option. But I think starting with just having it being complete would be nice.
So there's a few things you could do. You could, and this is maybe is the way I would do it, if that was your inclination, because you'll remember that on River City we actually had, I'm not sure how much you actually saw this code, but there was rectangle drawing functions, and there was like there was an outside rectangle and an inside rectangle. So if this was the rectangle that we wanted to draw, there's one that would draw like this business. Actually, I think you did see this code. Enough to know which one this is. So there's one that drew like the green business, and there was one that drew the red business. So
yeah, I think one of them was like draw rectangle inset or
inset. That's right, outset and inset. That's what they were called. So that's one thing you could do. So in fact, why not, just for the sake of exercise, because it's a good exercise, let's implement that. With the rounded thing, you can't really do it that way, because at the point that, like, in a sort of a generalized system, you kind of, maybe you have a line that's like that you're trying to do. And at that point, you've got a line here and like a line here, and it's like,
and I've got a triangle now.
That one is not a rectangle. Yeah, exactly. Yeah. And so that's the point where you want to like maybe do round circles, because then that ends up being a circle, and it looks pretty nice. But the other thing you have to keep in mind is that like this is pretty much for debug overlays. So unless customers are going to see this, you maybe don't care that much about how pretty it looks.
Yeah, I was thinking more in terms of going a step further than debug overlays and going towards like IM GUI type things where you're doing editing.
Exactly.
And so on.
So we actually have all the tools more or less. So why don't we work on all three of them? Do you want to like, we have another 15 minutes or so, maybe a bit longer. So do you want to try? We've got 3 things we could do here. We could do inset, outset, and rounded, whereas where rounded is sort of at least the maths involved in setting up rounded. So why don't we dedicate the rest of this time to doing those three things? Sound good to you?
Sure.
All right.
Yep.
Let's bring up the editor and okay. So what have we got here? We've got all of that. So let's copy this. And 1, 2, 3. We'll call them outline. Actually, no, copy 2. We'll call them inset and outset. Outset, outline, I guess. Inset. So what we're doing is drawing that same thing, but we're going to inset and outset it. So, yeah.
Well, right now we've got one that's doing sort of half in between both of those, right? Like,
yeah.
So we have to basically on one of them blow it out to the full, or I guess.
Yeah. So
add.
So this is the mathsy part that you're going to have to do some maths, because obviously the whole point here is to get you to do the maths. So let me draw some diagrams. Sorry.
I said, well, I don't want to, but
yeah, no, that's maths is hard.
It's fun though.
I do like a bit of maths. Okay, so we've got our points. You know, A, B, C, D. Let's do inset first. And we know that I'm going to draw this. In fact, I'm going to draw this. I'm just going to draw a corner. So we've got our starting point there, and we have, you know, this line that's we're drawing that way, and this other one that we're drawing that way. And we know that, what do we know? We know that the thickness is that distance there. That's the border thickness.
Mm-hmm.
So hopefully it should be sort of fairly obvious that what we want to do is more or less the same thing, but we want to sort of move this in by you know, border thickness divided by 2. So I'm going to move that whole thing in, and what happens is when we move this line in by that much and that line in by that much, they form like an intersection here. And so what you end up with is another rectangle like that, and it's more or less the same, you know, A, B, C, D thing, and they've just all moved in by the border thickness. So that's the goal. So we moved in A, B, C, D. So now it's your turn. So start basically coding that.
Yeah. Okay. Well. Okay. So from the starting at A, now I think it's like A's already been moved up by half just to get what we have. I'm assuming that's like assuming we're starting there and not actually manipulating that.
So what we so that point, that point is the red one. And
that's
then,
right.
Yeah.
Okay.
So we're
then we're just gonna do.
Yep.
We'll just do like super boring vector addition then. We'll just add the border BT divided by 2 positive to the X, and BT divided by 2. Maybe I'm just gonna make this its own thing. Just HW half width. And these are terrible names, but whatever. Actually,
probably half.
Okay, can I just scale?
Sorry?
Yeah, right. HT. I guess just looking at this, like, well, I only got one scalar, which is ht. I don't need a vector. I can just scale this, can't I, by ht? Because well, one's moving forward. Wait, y is down. A positive y is down. So yeah, in this particular case, I think that's the right thing. In the next case of b, I probably need to. I gotta go negative x to pull it back, and negative wait, y down, and I'm trying to move it. No, y is still positive, and then for c, I would need to pull it back. Well, I guess that's true. And for y, I need to actually subtract to go backwards there, and then d is basically I need to push it forward positively on the x-axis and pull it back negatively on the y. I don't know. I'll just throw in. I'm probably not there, but I'm gonna just throw an inset outline. See where I got.
Yep, that sounds like a good set outline.
That kind of looks right to me, but I'm not sure.
Close. Why don't we bump up the thickness a bit too? We might be able, in fact, thickness equals, I'm going to bump up the overall thickness to 40 as well, just to make it a bit more obvious. And you can see, if you look really closely, that you're almost right. And yeah, you've got got like an angular problem. In fact, if we were to change this to like 500, I think might do the trick. And I'm going to make this a bit darker so it's easier to see. I think this may, yeah, okay. So try a line like this, and you'll see that that there's obviously an angle problem.
Right.
Yeah. Or not. Yeah. It's not quite right, but that's okay. So
I'm missing the normal of the. Maybe I'm not. Go ahead.
So what I want to say is I'll sort of point you in the right direction, because
I'm assuming I'm axis aligned. That's what it is.
Exactly. So did you see the episode of 3 Blue 1 Brown about basis vectors?
Yes, but it's tenuous, my memory of it. But yeah, we talked about. Yeah, I've been through everything, including up through the matrices stuff.
Yeah. So what you've basically done is, yeah, you've added the half thickness, but you've added it assuming that it's axis aligned. So you've gone from here. It's like, well, half thickness
right.
that way and half thickness that way, which ends up, add those two together and you've got this point here. So you can see that that's offset like that. But it's sort of getting along the right idea, because you do actually want to do something like that. You want the half thickness that way and the half thickness that way, and you end up at this point here. So do you understand what I'm saying there?
Yeah, I do. Yeah, I just have to get it. I just have to get it in real life. And I just hoisted the normal.
I'm liking where your code is going. That's looking promising.
Okay. Well, don't make the wheels fall off. Okay, so I have the normal here, and then what I'm gonna do is I'm gonna basically scale this by the normal. Well, this should work because of the whole. Anyway, this might be bad, but I'm gonna do it anyway because pressing start is cheap. Oh, it was worked out better than I thought, I think. No, wait. What am I looking at?
This is supposed to be inset. I'm not sure that's right.
No, I can't really grok what I'm
plus. how is that even compiling? I'm trying to figure out how that's actually compiling.
Well, I thought that I was scaling this vector by the halfway, but I'm just trying to add that sort of. Wait a minute. Yeah. Am I missing an ATAN? Do I need ATAN in this?
No, because we're at the point now. We're at the point now that we're all we're working just with linear algebra stuff. We don't need trigonometry.
Right. So yeah. So I mean, I know that Z's in there. I'm trying to scale it by all of them, and maybe I'm only supposed to be scaling it by certain components in each one.
Well, first of all, let's get rid of x, because we know we're always getting that scaled by 2. Or rather, let's get rid of p, if you like.
I'm not sure what you mean.
Let's consolidate p and x down to one variable, because.
Oh, right.
Okay, so we've simplified a bit. We've got v, z, x, and the half thickness. Okay, so let's think about this. We've got z. Let's draw z on the whiteboard, because that's going to be useful. Z is the perpendicular, so and it's going 90 degrees, so it's going sort of downwards-ish. So it up in the top corner, and we're taking we're rotating 90 degrees to get the perpendicular from. Sorry, let's think about that a bit more rigorously. We've got start, and we've got end, which gives us v, which we still have, and then we're taking the perpendicular of that and normalizing it. So we've got sort of that's going off to wherever, and we are then taking the normal. So that's that. So that's our vector z in that code.
That's right.
So
yeah,
and then right, and then we're multiplying z by height by half to get the things we had before to draw the big line.
Right.
But now what we want to do is we want to go down this much on z to get down to there. So we actually want to go, if this is the half thickness, we want to scale z by that much to go down here. So,
okay.
And then which is smaller than whatever the line thickness or whatever is that we scaled z by. So we're scaling z by 2 different things. Now I'm going to try and catch up to your code just real quick, because yeah, so you are adding that multiplied by z. There's a name for this. There's some kind of product. I'm actually surprised that Vector 2 implements. It starts with an M. I can't remember what it is. Yeah, okay, so I've got that caught up to yours. So what's happening there is, and I'm making an assumption because I've never used this operator, because you rarely ever want to use it. You're taking the vector ht, so that's in client coordinates, that's ht to get this vector here, and you've got the vector z, which is this business here that's going normalized perpendicular, And what you're doing is you're just multiplying you're multiplying x and y with this one's, x and y. So what happens is it's whatever half thickness is. So you end up with a vector that's going, I guess, in the same direction because these are the same. Yeah, okay, so you multiply. Oh, actually, that's not too bad. That's kind of what we want to do. So, yeah, I guess what I'm saying is that, yeah. So this is a weird thing to do with vectors, and that is, this is identical to this. Whoops. And it's a weird thing to do with vectors, to like component-wise scale them, unless that's actually what you're trying to do.
Right. I was only doing this because of the idea that there's negatives in some of the components in the other
yeah.
C and D. But I mean, it totally makes sense that you can remove
because what because what you're doing, if you take negative ht, you're actually flipping this vector. You're ending up with, say, in one of those cases, the one with negative ht as the x, you're ending up with this vector here. And the thing about this vector here, that one, is that it never appears in this diagram, because that would be, and I'll draw it in blue, that would be like this vector here.
Right.
And so that...
Right.
Have I lost undo again? No? Okay. So, yeah, so that's not the right path to go down, is basically what I'm saying.
Okay, but the first one is, the second one isn't, basically?
So you're on the right track with the first one, because what you're doing is you're taking this normalized thing. So that could be...
Yeah, that's that green, the left green area.
That green thing could be like, that vector could be that big, and you need to scale it up to the half thickness.
Right.
Because that's just, unit length 1. So you're on the right track there. So you've got this vector here.
That's right. And then need to get the perpendicular of it.
Yes.
Right?
Yes.
So the perpendicular of z is just v already. Normalized norm form of v.
Exactly. Yes.
Okay. So now I'm going to do... I don't know what to do about this negative stuff, but I know that...
Sorry, I lost audio for a second there.
No worries. I was going to say, like, if I normalize v, I still don't know what to do with the component here, because if I just say this, I don't know if that's enough considering, or do I have to not do this negative part?
I'm afraid I seem to have lost video. You seem to have run out of internet.
Okay, I'm just saying for B. Basically, I turned Z to Z1 and Z2 into normalize of V. So where you have var Z, I've got 2 of those. I've got Z1, which that one is, and I've got var Z2, which is...
Let's draw this out. Okay, so... Alright, hopefully that's in. So we've got, these are old ABCD in these corners, and we want to go in. So what that means is we need to go that much in there, that much in there, and so you've already got these. This is Z1 and 2, which we need to scale still, which you're doing, so that's fine.
Oh, but in your case, My Z2 I put on the wrong one. Then my Z2 I put on B instead of.
But that's okay. So we've gone. So there is the various directions we need to go in by, this first one.
Yeah,
and you'll notice that some of those are negative.
Yeah,
exactly. I think you got it. And then,
yeah. So B is so A if Z1 is correct for A. Okay, sorry. I thought I had it for a second there. I'm basically going to be multiplying each one of these either by Z1 or Z2 plus or negative. I think, or
well, what I want you to
lost. I mean, I see your makes sense, but
what I want you to notice about this diagram is that all 4 points have both Z1 and Z2. So I think orange is Z1 and red is Z2.
Yeah. So, what are you looking at in the middle there? That's the sum. Seems like it's gonna do the thing. Right here, hold on. So let me see. For A, it's just weird. Okay, so A's correct, is it not?
A is not correct. So A, at the moment, what you are drawing is that.
That's right. That's right. Okay. So, what if I, to get, I know I should know this. I know this. I'm not going to if I what happens if I add them? Yeah, what if I add them? Z1 and Z2.
Okay, well, do you want to type that in so I can see what you mean? But I think you have it. That's reasonable. That is reasonable. I'm going to make a quick suggestion here.
Okay.
And that is you will find it easier to do this if you split that out. So if you I forget what the term for this is. Whatever the opposite of factorization is. If you take that HT and put it inside the brackets, so HT times Z1 plus HT times Z2. And hopefully you know how that works algebraically, yes?
Yeah, sort of. I mean, yeah. I mean,
so
I don't want to go back to lesson 1. But
we've done the opposite of simplifying that expression, which I forget.
That's right. Yeah.
Forget what that's called.
Expanding.
Yeah, expanding. Yeah. We'll call it expanding.
Okay.
That sounds about right. So yeah. Okay. So that's a good start.
Okay, so let's do for B. We have these different components here. So this Z1 and Z2. This might be harder. Well, I think I'm gonna add. So I'm gonna add the. So we want the negative Z1. Oops. Negative Z1 times HT plus Z2 or HT. Hold on. HT times negative Z1 plus HT times Z2.
That's looking pretty good to me.
Okay.
Although you'll want to get rid of that new vector 2 stuff from earlier.
This?
Yeah.
Well, I don't know how to because of the negative component. So, hold on. Maybe I just
because that's old stuff. Because that's we already know that is the wrong vector. Like that's.
Oh right, sorry. Yeah. I thought that was part of the yeah.
That's adding like. That nonsense or whatever, or not quite.
Yeah. Okay, I get it there.
Yep.
Okay.
That's all right.
Good. Okay. Right. So let's just do the other silly things here. So HT. I'm doing C, so that's going to be positive Z1 plus HT times negative Z2, and then HT times negative Z1 plus HT times negative Z2. I don't know. Let's do that.
Let's try it. Run it.
I gunked on something here.
That's okay. So I think what's happened is you've got some of those backwards because it looks like, and it's a bit hard to see because I'm looking at yours. It looks like you have just made some sort of minor mass error because you'll notice that some of those are inset and some of those are outset.
Yeah.
So let's just try and now you sort of got it. Let's just try and quickly fix up that code there. So I'll try and catch up to where you're at.
B. Definitely negative Z. So C and D are probably the wrong ones because they're kind of thicker at the edge. I know A and B are probably properly in set C. Or actually, B and D look like they might be.
Yeah.
So B would be.
Okay. Yep.
I'm just trying to think. And so B, I must have done incorrectly. I think this one's right. It's. I don't feel like it's this. I don't feel like B is wrong though, but maybe it is. That didn't help me at all.
That's okay. I'm just looking at this on my screen and I'm trying to figure out which ones are wrong. Because this is where it gets a bit interesting because you need to know which ones are like A, B, C, and D. So A, I think, is that one. End minus.
Well, I can put different colors on them.
X. That's true. End minus X, which is that one. Okay. And then that's so
you just flipped B, hey?
I'm just like, well, maybe we just flip them around, and like this is a case because we haven't been particularly rigorous about which one is which. What happens if we just flip them around and sort of brute force it?
Cartesian whack-a-mole.
Yeah. Right.
Well, why don't we be rigorous about which ones they are? Maybe that would be helpful.
I think that's right.
Although we're kind of out of time anyway.
I think, well, yeah, because we're out of time. We have to maybe.
Well, I can probably. If all we're doing here is getting the right, you know.
So you'll notice on mine that I've got the inset correct. Now
the magic formula.
I do notice a minor flaw with this, and that is, you could actually. I didn't really think about this when I was setting up the exercise, and that is that in fact you may actually want to have the points because we've done the maths. That's sort of the important bit. But if you actually wanted to use this for a realsy thing, you probably want the points there and there and there and there, which gives you those lines. and then you want the points there and there and there and there, which will give you these lines, and then it will look a lot prettier. But then you need, rather than 4 points, you need 8 points.
Right.
So I think we're going to have to finish off there because we're pretty much out of time.
Yeah.
But sure. So I would encourage you to do a few things. So I'll tell you where we're going to go with that. Whoops. Let me new layer this, and I'll send you this diagram for like homework purposes. So what I wanted to do is we had the inset one where we came inset and did these 4 points there and drew that rectangle, and that's exactly what we just did. Then there's the outset one that's like the same thing, but that and that and that and that is more or less the identical exercise, but you flip it, like you pretty much already done this. It's like we just got all of the negative signs changed, so you could do that.
That's right.
So I would encourage you to do, because I mean that's more interesting because we just discovered it, and that is do the exercise where you draw the lines there, like there and there and there and there, because that's sort of, you know, the pretty version. And do the opposite as well, so like there and there and there and there, and like you'll notice that, you know, when you add thickness to these things, they all like and they line up and abut nicely. So those are like the 4 cases that I think is probably worth implementing.
I'm not 100% sure I can see the difference between these versions, other than that you're drawing them in green.
So I'll finish drawing out the outlines of the.
Sure.
So actually, yeah, so
okay. So it's just like thicker, basically, on the outside.
So this is in this case we're drawing 4 lines. Like in this case we're drawing 4 lines as well, but you know like in this case here, you get the situation where you've got that ugly missing corner, and you know, and so on. Like there. Whereas this, but you only need like 4 points, like that's B, for example. Whereas this one, it's got 1, 2, 3, 4, 5, 6, 7, 8 points to calculate. And same with this one. This is the inset version of that. So so that's the pretty 8-point version. This is the other 4-point version. The final thing that I was going to suggest, and this is maybe a bit more of a you know, this is taking it a bit further. So I do these in order. So we've already done that one. Do this as number 2, 3, 4, and if you want an extra challenge, we'll talk about the round line version, which is like if you actually wanted to do rounded edges, you know, we've already done the outline. The whole point, well, one of the points of the outline version is we had a line there and a line there, and we get this line here. Let's draw out the 4 points we need if we were going to triangulate this sucker, and stick a triangle across there, and then we've got 2 triangles that we can render on the GPU and be like, well, there's our thick line that doesn't use sprite batch. If we wanted to round it, we'd have to stick 2 extra things on there and stick like a texture or a shader that would be like a semicircle. And in order to do this, when we go to draw that, we'll have a triangle here and a triangle here, more or less. So we need that point there, and that point there, and that point there, and that point there. So now we have extra points to draw. And so the idea of this final exercise was like, right, calculate these 8 points here, and just draw lines between them for now, just so we have the maths right for drawing those lines. So do you follow what I mean by that?
Yeah. Yes. Other than, I mean, wouldn't we just want to draw a circle already at that point? It matches the color of the thing.
So I mean,
the point and the radius. So.
If you're really keen, you could just slap together a circle texture and do that if you like. But I do want to move towards a point where we can actually draw the triangles. So that's sort of the reason that we're using like line rather than the thing we started with, which was, draw the sprite batch thing and stuff. Because when we have line, we have points A, B, C, D, stick them in a vertex buffer, send them to the GPU, and stick a. Remember we talked about index buffers. Like, right, there's one triangle. It's like there's one triangle, and then I forget whether that's actually right. But there's a second triangle. We have triangle A and triangle B.
I remember.
Yeah. So that's sort of where we want to maybe push towards, because then we can actually draw this in a nice way. So off stream, just because I don't have it prepared, I don't mind showing it on stream, but
that's fine.
I don't have my thing. I'll show you what I have for that. So let's wrap that up. So thanks for watching, YouTube. I'm going to stop recording now. So we'll catch you next week, YouTube people.